This is lesson 4 in our books. Lesson 4 covers a whole lot. It's a lot of review of basic operations of arithmetic and other things. I'm not going to get into all of that because, like I said, it's basic review. You can look over those things for yourself. There is one main thing in this lesson, though, that always seems to confuse people. I've even had some requests for this one from some comments. So I want to definitely take some time to cover it. It's on conversions of length. It's using what's called unit multipliers. These seem to really throw people for a loop, but if you follow some simple steps on these unit multipliers, you're going to find out that they're actually really easy. Now, before you can do a unit multiplier, there's a little table in our book with some conversions that you need to know. These are things that you just have to know. You have to memorize them. They're good to know because it helps you whenever you're converting these measurements. These are the 6 basic ones that you want to make sure you memorize. We've got our US measurements, like us Americans are used to, and then we have the metric measurements, which a lot of times we're not as used to, but we should become familiar with them because you use them a lot in science. You're going to be using metric measurements. And then we even have one that we can use to convert between the two. And I forgot to write centimeters right there. But the measurements are 1 foot has 12 inches. Hopefully we learned that a long time ago. 1 yard has 3 feet. And then 1 mile has 5,280 feet. Those are our US measurements. There's a couple main metric measurements we want to know. 1 meter has 100 centimeters in it. 1 kilometer has 1,000 meters. And then this is the one we use to convert between the two. 1 inch is made up of 2.54 centimeters. And it's important that we know how to convert between the two. I always like telling my class that we managed to crash a space probe into Mars a few years ago because we did not do conversions properly. I don't remember the exact story, but I know that when they built this space probe, they did it according to US measurements maybe, and then when they did the calculations for getting it to Mars, they did it based on metric measurements, and so instead of going into orbit of Mars like the thing was supposed to, it crashed into it, and so, you know, however many millions or billions of dollars were lost. So we want to make sure we know how to do this. We use what's called unit multipliers whenever we're doing these type of problems. I want to do a real quick example. We're going to find out that these follow the same steps no matter what. One of the examples they give us in the book is they want us to use 2 unit multipliers to convert 42 feet to centimeters. So what we do with these problems is we take the number they give us in the problem. They ask us to convert 42 feet, and you want to put the unit with it. And what you're going to do is that number they give you in the problem, you're going to write it as a fraction over 1. Every single one of these problems we ever do, that number they give us and ask us to convert, we're going to put it with its units, whatever that may be, in this case feet, and we will put it as a fraction over 1. And then a lot of times they tell us how many unit multipliers to use. In this case, they told us to use 2. So I'm going to go ahead and put times, and I'm going to set up a fraction, and then times, and I'm going to set up another fraction. And that's going to be our 2 unit multipliers. And the problem asked us to change 42 feet to centimeters. So that means we're starting with feet, we're ending with centimeters. So I'll put centimeters in at the end. And this is going to be really important. When we start setting this problem up, this took me a while to figure out when I first learned to do this. It's really important that you wait to fill in the numbers from our conversions until the very end. Because if we don't wait, we end up trying to kind of guess where the numbers go, and that doesn't work. What you want to do is you want to put the units first, and the units tell us where the numbers go. I'll show you why. We're changing feet to centimeters. We need to figure out what comes in between them. Now, we only know how to change feet to 2 different things. We know how to change it 2 inches, and we also know how to change it to yards. Neither one of those is going to help us very much. We could also change it to miles. That's not going to help us very much there. So what we need to do is we need to figure out which one of these works best. What comes between feet and centimeters? Remember, there's only so much we can change centimeters to as well. We can change it to meters, or we can change it to inches. So think about what we're doing here. We are converting from a US measurement to a metric measurement. So that means in between them, we need to use the conversion that goes from US to metric. In this case, from inches to centimeters, because we know how to change feet to inches right here. We also know how to change inches to centimeters. So that's what comes between the two. So we'll fill in inches right there. And then the units that go on the bottom are very, very easy because you just look diagonally at what we already had. Since we started with feet on the top, feet will go at the bottom of that first unit multiplier. And then since we had inches at the top of this one, inches will be at the bottom of our next unit multiplier. And so we fill in all these units before we put the numbers that go with them. The reason is now we don't have to guess where the numbers go. If I know the conversion for inches and feet, I know there's only one correct place to put those numbers. I can say that 1 foot has 12 inches. If I said 1 inch had 12 feet, I'd be saying something ridiculous because that's not true. Same thing with the centimeters and inches. As long as I know the conversion, I know that 1 inch has 2.54 centimeters. If I wrote it the other way, it wouldn't make sense. 1 centimeter does not have 2.54 inches. And so we end up with this multiplication problem. And what I do with my class is, for these unit multiplier problems, I have them set up the answer as a math problem. Because by this point, you know how to multiply, you know how to divide, and this is not a multiplication and division problem. This is making sure you know how to set up the multiplication and division problem that will give you an answer. And so as long as you can set it up properly, there's really no need to do the actual multiplication and division, because if we had to do that, if we're doing a project and we need to figure out this conversion, we're going to set it up and then we're going to do it on the calculator. So there's no need to work it all out by hand as long as we know how to set it up properly. So what I let my students do is I let them just set it up as a math problem. And so the top part is all being multiplied. The bottom part is all being multiplied. And so what I have them do is I have them just write it as 42 times 12 times 2.54, and our answer is in centimeters. And technically all of this is a fraction over 1 times 1 times 1, which means it's a fraction over 1, which means it's a whole number. There's no need to write that over 1. So this is what we get. And if you were to do this multiplication, 42 times 12 times 2.54, that would be how many centimeters are in 42 feet. So we will look at one more example real quick and we'll move from there. So our other example is asking us to change 4 miles to inches. We'll set it up exactly the same way. We'll start off with the number from the problem, 4 miles. If you want to, you can write it out, or a lot of times I'll just write MI for miles. We'll do 4 miles. Remember, that number in the problem is always a fraction over 1. It tells us to use 2 unit multipliers, and it tells us that we're changing miles to inches. So we will end with inches. So think about what comes between the two. What comes between miles and inches? Well, the only thing we know how to change miles to is feet. So automatically we know that it's going to be feet. And then it'll be easy to change feet into inches because we know how to do that as well. Remember, we do the units before we fill in any numbers. So next we want the bottom unit. We just look diagonally to what was at the top. So that's miles again. And then same thing for this unit. We just look diagonally to what was up here, feet. Once we get all the units in place, we put the numbers in, and you put them in the only place where they make sense. The only way we can make this make sense is if we write 1 mile has 5,280 feet. If you write 5,280 miles or in 1 foot, you've made a ridiculous statement that is in no way true. So the unit tells you where the numbers go. Same thing here, inches and feet. You have to know that there's 12 inches in a foot, and you just fill in those numbers, 12 inches and 1 foot. And so we've got our multiplier set up just like we did in the last problem. Once again, just like in the last one, our bottom, our denominator is 1 times 1 times 1, which means we don't really need to put it. Instead, we can just write out a multiplication problem for the top. 4 times 5,280 times 12, and our answer, of course, is in inches. Now, for both of these examples, we ended up with just 1 on the bottom. But sometimes when you work these out, you will end up with whatever number on the bottom, a 12 or a 3 or 5,280. If that's the case, then you write your answer kind of like a fraction. You write it over and then however much on the bottom. So this is just basic conversion of length. It's done just like this. Later on in the book, it talks about conversion of area and conversion of volume too. Those also use unit multipliers. But once you get this basic conversion of length down, the other ones are really simple because you're just adding in an extra step. So if you can practice on some of these should be simple problems. What I always tell my students is that they don't involve math, really. You're not really having to add or subtract or multiply or divide. Really what you're doing is setting up a problem that does that. So the main thing, make sure you know these conversions. You got to memorize them. It's just 6 of them. It's not bad. Commit them to memory and then follow the same steps each time to set this up, and you ought to do well. If there's any questions, just hit me up in the comments. If you got any more suggestions, let me know. I'll be happy to help out, and we'll see you next time.